This is the second part of the periodicity of properties. Topic of this video is periodicity of ionization energies, first group, and along the second period of periodic table involving shielding effect and atomic radii. Periodicity is the study of variation. By periodic law, different elements have different atomic numbers. These variations show in chemical and physical properties of the elements in periodic table. So, lithium is least reactive, hard to lose one electron as compared to cesium, that loses one electron easily and is most reactive. It means cesium is easier to ionize than lithium. In group trends, lithium has 3 electrons. The electronic configuration is 1s2 and 2s1. Sodium has 11 electrons. Its electronic configuration is 1s2, 2s2, 2p6 and 3s1. Next to lithium, sodium is easier to ionize than lithium. The reason is the shielding effect. Lithium has 2 orbitals in it and 1s and 2s. Sodium has 3 orbitals, 1s, the second orbital 2s, 2p, and the third one 3s. By the electronic configuration law, lithium has 1 electron in s shell of second orbital and sodium has also 1 electron in s shell of third orbital. 3s electron in sodium is easier to remove than the 2s electron in lithium due to shielding effect. It means increase in shielding wins over increasing nuclear charge, and increasing nuclear charge wins over shielding, 2 dips. Now lithium to neon, the trend for ionization energy to increase as the nuclear charge increases. This must also mean shielding is not so important across a period as it is down the group. Along the period, you can see we will observe the filling of p orbitals. Look at here that px, py, 2px, 2py and 2p orbitals. They are right angle to each other. P orbitals are mutually right angle to each other. Electron in p orbital has little shielding effect on electron in py and pz orbitals. Thus, to a large extent, they do not shield each other from nucleus. Because 2 orbitals gain electrons along the period. In boron, 2p gain 1 electron. Carbon 2p orbital gain 2 electron in ground state. Nitrogen 2p orbital gain 3 electrons and oxygen 4 electron in it. Now you can see the electronic configuration of beryllium, boron, carbon, nitrogen and oxygen. There are 2 bumps or dips there Because reason is px, py and pz orbitals are mutually right angle to each other. Electron in p orbitals has little shielding effect on electron in py and pz orbitals. Thus, to a large extent, do not shield each other from the nucleus. Two dips in the second period of elements between beryllium boron and nitrogen and oxygen. From beryllium to boron, ionization energy decreases here. Now look at this. Beryllium to boron. The filling of 1s or 2s orbitals will have shielding effect because s orbitals are symmetrical. In beryllium, first s and 2s have 2 electrons each. They are affected by the nuclear charge. Within boron, after filling s orbitals, next to p orbital gain an electron. This electron will feel the effect of shielding by the pair of the electron in 2s orbitals to lower down the ionization energy as compared to beryllium. So decrease in ionization energy occurs rather than increase, as that is just what would we expect. Now look at the graph, look at the dip. Here again the atomic number and their first ionization energies. Now lithium to beryllium, boron, then again boron to carbon. Increase from boron to carbon reflects increase in nuclear charge. 2s electrons in excited state are in different orbital of carbon. They are 2s, 2px, 2py and 2pz contain 1 electron each. The reason is 2p electrons are in different orbitals having little shielding effect on one another. So increase in ionization energy occurs. Similar state arise from carbon to nitrogen. Next is nitrogen to oxygen, a dip. Look at here, the orbitals you can see 1s, 2 electrons in 2s, 2 electrons are there in 2p orbital, one of them, one of 2px, 2py and 2pz contain 1 electron each. Ionization energy of nitrogen is 1402 kilojoules per mole. Now for oxygen, look at here the 2 orbital. It contains 1314 kilojoules per mole, less than nitrogen. The p orbitals contain a more electron in its px orbital, 2px orbital. Observe this electronic configuration of nitrogen and oxygen. 1s and 2s orbitals are complete, having 2 electrons in each. In 2p orbital, px, py and pz have an electron in each. According to nitrogen, 1s and 2s orbitals also contain 2 electrons each. Next, 4 electrons adjusted them in px, py and pz orbitals. Px has a pair of electrons in the same orbitals, brings about between them the repulsive force, and that repulsive force creates a dip. Dip can be seen in the graph in the previous one. With increase in number of electrons, ionization energy decreases. Now, the oxygen atoms have extra electron that must go into a p orbital that has already an electron in it. Two electrons in the same orbital brings about repulsion between them. This effect outweighs the increasing nuclear charge from nitrogen to oxygen. It is easier to remove an electron from 2p orbital in oxygen containing 2 electrons with repulsive force. The similar orbital in nitrogen containing only 1 electron. This effect outweighs the increasing nuclear charge from nitrogen to oxygen.